The coming up presentation by Shri H.K Raghu, Senior Professor Rolling Stock, IRITM Lucknow. He is from Indian Railway Service of Mechanical Engineering 1989 batch. He did his graduation in Mechanical Engineering from IIT Roorkee in 1987 and post graduation from National Institute for Training in Industrial Engineering in 1989. In Indian Railways, he started his career as an assistant work manager, Matunga Workshop. Growing in his career, he had worked in various capacities like Senior Professor Diesel Technologies, Indian Railways Institute for Mechanical and Electrical Engineering, Additional Divisional Railway Manager Dhanbad, Chief Workshop Engineer, Modern Coach Factory Raebareli, Chief Project Manager, Modern Coach Factory Raebareli, and then Executive Director Coordination, Urban Transport and High Speed Directorate RDSA Lucknow. Over to you, sir.
Really, it is a wonderful day for me that I am going to present a different scenario of transportation sector in which we will be concentrating basically on how we have to justify the metro rails and especially the metro light. Because the metro projects are very costly, and when we justify it, we give our work to some consultant who make the detailed project report for these projects and try to justify it with the PHPD. And finally, when the metro project takes takes the shape, then we find that it is not able to generate the revenue which is desired from it. So I am H.K Raghu, Senior Professor Rolling Stock, IRITM Lucknow, and I will be discussing in next few minutes how we can justify the metro other than on the revenue. We see only the revenue part, and then we are worried after making the metro, the non-revenue part also, because the total revenue coming to us is not justifying the project. Even as on date, if we see, most of the metros are running maximum at the 12% to 15% of their revenue generation capacity and what has been projected. Even the Delhi metro is running, which is the most crowded metro, it is running at the total efficiency of, not efficiency, it is the total revenue generation, what was projected, about 30 to 35%. So if we see only the revenue generation part of the metro, it may look like that it is not sustainable. But instead of seeing only the revenue generation part of the metro system, we are going to give you a different perspective in which you will understand that why we should not justify the metros and just go for it. And why we are considering metro light, because the metro projects are generally elevated, either generally elevated or underground. But all these projects are becoming costly because of their underground or in this elevated condition. So instead of that, the new concept has come. It is metro light. It is at grade metro, and it will provide you all the facility except it is not underground or it is not elevated. It may be elevated at some of the places. It may be underground at some of the places, but majority of the metro project will remain at grade. So how we select a technology, that we have to see. In general, we select a technology based on it should be long lasting, and then it should be energy efficient and effective. Then it should be self-reliant, means we should have that technology with us and we should be able to develop it further in-house. Then next comes the eco-friendliness. How much weightage we give to eco-friendliness, it depends upon how much knowledge we are having about the eco-friendliness of the system, or how much budget it is going to take away in the shape of taking the step towards saving the environment or our health. Then we see the sustainability. The sustainability, basically the project, whatever project is there, it should sustain itself. Basically, it should generate the same revenue, and we should not require any fund from outside. But let us see whether we require fund from outside or we can generate fund ourselves. Then comes the acceptability by the common man. Whatever mode of transport we select, we have to see the acceptability of it by the common person. Then it should be cost effective and low maintenance cost. and then finally the availability of fund and the political will. We have seen different kind of mobility in the cities like car, taxi, buses, cycle, pedestrian, metros, tram, trolley, and private car. And few other modes of transport you can see there: airplane, subway, taxi, buses, tram, railways, bike, cableway, and the ship. But now we divide all these transportation system in two different categories. The category number one is road and rubber tire. Here we use the road either made of asphalt or cement. Then we run over it the two-wheeler like bicycle, mobile, and scooters, and the three-wheelers, auto rickshaw and battery rickshaw, and then four-wheeler like taxi, minibus, city bus, trucks, and finally we are heading towards the electrical buses and electrical trucks. Second mode is railroad and steel tire. In railroad and steel tire, you see the Indian Railway, Metro Rail, Metro Lights are there, and then the dedicated freight corridor for goods transportation. Now coming to why we should avoid the personal vehicle. So you can see the comparison. For transporting 50% at one place to another place, we require the road, and you can see the road occupation by the pedestrian. And the first side on the left side, you see the pedestrian, 50 pedestrians are catching hold of the that much of road, they are grabbing the road. Then the 50 cyclists are there, then 50 people in a bus. And then if we use the personal vehicle, the 50% in 33 car, you can see the how much amount of road we need to run if we use the personal vehicles. And now coming to the carry 50,000 people per hour per direction in a city, we normally require a 175-meter wide road used only by the cars. If we have only the cars, it requires about 175-meter wide road if we have to carry 50,000 people per hour per direction. But if we switch over to buses, it is again very big. It is 35-meter wide road, and you can see since the space is now reduced, then we are having space to put some greenery over it. And when we go for the metro, it requires only 9-meter wide track, and lot of greenery are there from one side to other side. Now coming to the pollution. Normally when we see the pollution is seen. Seen means whatever we can see. But there are some pollution which we cannot see. So we will be seeing here the pollution exhaust versus non-exhaust. Till now we are concentrating only on exhaust pollution. Thereby we are taking all the steps. Whereas this chart shows that exhaust emission is only 14% out of the total pollution created by the vehicles. And remaining 86% is either from the wear of brake or wear of tire or road wear, and then the resuspension created by the vehicle when it drives on the road. Why eliminate rubber tire? Why I am so concentrating on eliminating the rubber tire on the road? We will see the tires are the plastic polluters, and they are sleepy source for all pollution. What are the environmental hazard? The environmental hazard, if you see, by 2015, about 322 million tons of thermoplastic was created for production of tire. And out of that, by 2010, about 12.7 million ton has gone into the sea and river. Pollution of the environment with plastic is recognized as a serious global threat because it can negatively affect the human health, aquatic organism, as well as the economy. Tire wear and tear is a sleazy source of microplastic in our environment, which can only be addressed effectively if awareness increases, knowledge gaps and quantities and effect are being closed, and creative tactic solutions are being sought. Now let us see, the tire is made of what? The tire is made of basically the natural rubber, but natural rubber then is mixed with the crude oil for the concept for giving the shape of a tire. And tire is basically made about 19% of natural rubber, 24% of synthetic rubber, and for making the tire for one car tire, about 7 gallons of crude oil is consumed, and for making one set of truck tire, 22 gallons of crude oil is consumed. So producing tire still is a monumental environmental impact. Number one is deforestation. We are removing the trees which are not giving the natural rubber, which has stopped giving the natural rubber. And similarly, climatic harming fossil fuels are used to make the synthetic rubber. But what is also becoming increasingly clear, that as the rubber wear tear throw off tiny particle polymers that often end up in the pollutants in ocean and the water. Non-exhaust emission, if you see, this chart gives you the just a comparative figure, how much tire wear, brake wear and road wear can create the pollution. And the top portion, the black portion, you see that is the for more than 10 micron particles, and the gray portion is 2.5 micron particle, and then dark gray portion is the 2.5 micron particle. And what is the problem with the 2.5 micron particle, which is known as PM 2.5? It cannot be filtered by the normal mask which we are wearing at the time of driving our cars, or we are going outside in the environment. So that is very, it's the cause of concern that 2.5 micron particles are to be taken care. On an average, its emission in 2.5 particle is 5 milligram per kilometer. If we say if a car drives 1 kilometer, it creates about 5 milligram of PM 2.5 pollution. Then there is some just a figure given to you. This figure is taken from the satellite. It appears to be very nice figure, very artistic figure, but this is the basically figure of a tire dump. If we go from the near side, near view, this is the near view of the tire dump, and you can imagine if a thing can be seen from the satellite, how much huge tire dumps are available on the earth. Then you burn the tire amass for destroying them. So this is also one of the major cause of pollution. And if we see the story of rubber tire, the rubber tire started with the invention of a new method which is known as vulcanization for making the rubber more flexible and durable. It was started in 1839 by Charles Goodyear. Then in 1888, John Dunlop invented the air-filled pneumatic tire for bicycle. And 1911, Philip Strauss invented the first successful car tire. Modern tires are made of synthetic rubber, wire, plastic-based fabric, and other material. Tire wear generation scale. If we just see the scale of tire wear generation, about 2.5 pound of rubber is being generated in the average life of 6.33 year of a tire. So this is found from the study. Similarly, if you see, about 1.8 million tons of microplastic is being generated by US every year. One tire particle, once the particle is made into river or ocean, they can affect the noticeable effect on the marine life. John Winston at the Citadel exposed the shrimps to tire particles in lab setting and found that the animal ate the particles, which also got stuck in their gill. Once ingested, particles build up in the shrimp's guts. So if you eat the shrimps, then it will go in your guts and it will remain there. It will not be digested. It can create various kind of problems. Estimated pollution. If we go to estimated pollution for considering urban, rural, and highway roads, then we find that the maximum particles which are created by this tire wear are concentrated, is accepted by the big pores on the road and concrete asphalt. But total is about 17,300 tons tire wear is there every year. But if we take about 95% is captured by the asphalt, even 5% go into here, that will be about 8,834 tons per year. Now, looking at the country worldwide, if we consider a study has been done where these 4 countries, Netherlands, Sweden, Norway, and Denmark, they are creating the tire emission dust in the range of less than 1% of total world population, total world creation. And then comes the Germany, United Kingdom, Italy, and Japan, which are below 5% of the total world pollution creation. Then our beloved India and Brazil, who are more than 5% of the total creation. And the worst is China, Australia, and USA. And Australia, you can see, is the worst. At 36.69% pollution is created by Australia itself. So finally, you see about 4,900,000 tons per year dust is generated from the tire wear. Number of vehicles on the road, if you see, it has grown up from 1920 to 2020. You can see it has gone from starting from 50 million vehicle per million vehicles to 1,200 million vehicle by the end of 2019. Pollution cycle of tire wear particles. If you see how the pollution cycle of tire wear particles is there, when your car runs on the road, it creates about 15,030 tons of the wear and tear particles. Out of that, about 1,040 tons goes into the air, which is very tiny particle in the range of PM 2.5, which are inhalated about 3 to 7% by the human being. You can see the human here, which is shown purposefully in the black color, because the tire is tire is basically in black color, and by consuming the dust of the tire, its body becoming black and black. And similarly, the atmospheric, when it is going into the water, and through WTTP, about 1,337 tons of particles are going in WTTP. But WTTP also releases some of the effluent. That effluent carries about 523 tons, which goes into river. And finally, if we see from the road, whatever water is not collected by WTTP, about 520 tons are going into river, and finally in the ocean. From the ocean, when you consume the seafood, it is through oral exposure that you are being affected adversely. PM 2.5 particles. What is PM 2.5 particles in the air? If it becomes, then stay in the air for weeks and travels more than 1,000 kilometers. The contribution of tire wear and tear of airborne PM10 has been estimated in several studies, mostly focusing on quantifying the contribution of non-exhaust PM emission related to exhaust PM emission. 50 to 80% of total traffic PM10 emission is originated from the non-exhaust sources, and the large variation is due to factors such as the degree of precipitation is less under the condition, road surfaces characteristic, and the type of tire. Tire wear and tear is typically expected to contribute least for non-exhaust sources, that is resuspension, road wear, brake wear, and tire wear tear. Now, seeing to the health effect, ultimately human and ecosystem can be exposed to the tire wear and tear, released into the environment, and for human the most relevant exposure route is inhalation of the airborne particles. Marine and other aquatic organisms may also be exposed to tire wear and tear through ventilation, gills, and feeding. Filter feeders and sediment dwelling organisms can also be exposed. Many of these organisms, that is mussels, oysters, are important commercial seafood and species. Hence, the question arises whether human health may be at risk due to the consumption of polluted seafood. These human health issues are discussed in more detail below. If you see the death due to air pollution, globally about 42 lakh people die every year because of the air pollution. And if we see our India, about 30.7% of death in India can be attributed to air pollution. That means about 25 lakh people die every year due to air pollution. Death in India due to air pollution has increased from 1990. If you see, it is 13.33 lakh person above the age of 14 years. It has gone in 2019 as 16.67 lakh people. Health effect from the inhalation. Using PM 2.5 as an exposure metric, the World Health Organization recently estimated that outdoor air pollution was responsible for 3 million deaths globally in the year 2012. This suggests that the tire wear and tear are contributed to the global health burden due to air pollution. However, unambiguously, conclusion cannot be drawn since it is not yet known the component in the PM 2.5 contribute most to its detrimental effect, which is yet to be studied. This stress urgency of the identifying those components. Health effect from food intake. Exposure to organic tire wear and tear extract led to genotoxic effect due to oxidative stresses in human lungs. It means if you are being affected, then your offspring will also be affected automatically like a genetic disease. Now coming to the mitigation measures. First mitigation measure which is offered by the people is recycling of tires. But once you permit this recycling of tire, you do not reduce the production of the tire and thereby you're not reducing the number of tire on the road. Second mitigation measure is to reduce the production. Here you can see, it is seen that in 1990, the 1,000 million tires being produced, which by 2017, it is reduced to 60 million. So it may look to you that it is very good that we have reduced from 1,000 million tons to 60 million tons tire. But if you really see what is happening, what the tire has not been produced, but people have started the retrading business. Retrading business is filling the gap of the total requirement of tire. Since the total number of vehicles are increasing on the road, the total number of tire are not actually reducing. Now coming to the next mitigation system, if we see the as per as 28% of the microplastic in the ocean comes only from the tire shedding synthetic rubber as they wear down. So the first mitigation measure is suggested by the engineers is wear resistant tire. But when we go to the wear resistant tire, there is a concept of a magic triangle. Magic triangles basically says that the relationship between the rolling resistance, slip resistance, and the wear resistance improves. If you improve one, another will increase. Therefore, you are compromising on other things. If we reduce the wear, then we may be compromising on the safety because of slip. Second thing, we can go for the electrical cars. If people are saying for reducing pollution, we can go to the electrical car. But electrical car is only reducing, as apparently seen, that the exhaust pollution. But till the India is going for total nuclear power plants, we are producing much more pollution in the power plants than what the actual petrol car or diesel car is producing per kilowatt. So it can be concluded that the current electrical car will not solve the particulate matter problem. And one more thing which we have seen, that the electrical cars are heavier than the petrol and diesel car because of its battery weight. And because of that, the tire wear will increase if we use the electrical cars. And you can just see the piling up of the battery scrap. This is only one photograph shown of near New Delhi, and it is about 200 to 300 such kind of battery piling yards are there. So they are also problem for the major pollution problem for the country, and that is to be taken care. Now coming to the self-driving car. So to reduce wear and tear of tire, you can say we will go to the self-driving car, which senses several things and take the turns accordingly. So reduce the tire wear. So definitely it will reduce the tire wear. But whether it is going to contribute to that extent, this is yet to be seen, because again the magic triangle comes here and it takes care of the maximum advantage of the magic triangle and give you the optimum wear and tear, but it will not reduce the wear and tear. Now you can say that whatever wear and tear is there, we will create a wastewater treatment plant. But if you want to create the wastewater treatment plant for which it is really going to help us, that is very costly, and it is going to cost to the world very expensively, and we will not be able to take care of all the. Then civil engineers come into picture. They will say that we will give you the road which is open asphalt concrete, which absorb all such kind of wear. But that wear absorb, even if it is 95%, the 5% goes into wear, which is very high. So the pavement material is an important factor of the tire wear. The pavement could be designed to reduce. Now we are making these cement roads, which are causing more wear and tear. So either we use the durable road or we use the durable tire, we are not going to reduce the problem. So finally, we conclude that it can be concluded that the tire wear and tear is a sleepy source of microplastic in the environment. This can only be addressed effectively if awareness increases, knowledge gaps are being closed, and creative solutions are being sought. This requires a global effort from the stakeholders, consumers, regulators, and industries and resources alike. Now, let us see the budget on health. How much budget we are giving on the health concern. About 86,200 crores was sanctioned in 2022 to 23 for health budget, which was about 16.6% more than the last year. And if you really see, last year we have expended finally 86,000 crores, and this year we are going to spend more than 86,200 crore because the health problems are keep on increasing. Budget estimate on the National Health Mission is also there. In that, in 2022-23, we are giving 37,000 crore of rupees, which was earlier 34,000 rupees. So it is also increasing year by year. Then coming to the Pradhan Mantri Swasthya Yojana, we are giving about 10,000 crore rupees in this year. Last year it was 7,400 crores. So this is also increasing. So health budget is increasing. We have to see that. The total health budget, if we see, it is 1,33,200 crores. Now, budget on the road transport. If we see the budget on road transport in 2022-23, it is about 1,99,108 crores. And last year it was 1,31,149 crores. The beauty of this is it is about 52% higher than the last year. But again, if we see the consumption pattern, the budget which is consumed by the road expenditure in percentage in 2015-16 is 103%, in 2018-19 is 109%, and 2020-21 it is 111%. So you see the amount of budget being given to the road and its utilization. So the roads are coming very fast, and the vehicles are also coming very fast on the vehicle. Now you just see the railway and urban transport budget. In 2022-23, about 1,40,000 crores were given to railways, and for RRTS only 4,170 crore has been given. And regarding other urban transport, it says that innovative ways for funding, financing, and fast implementation will be encouraged for building metro system for appropriate type of. It means the budget is not there for creating metro systems. And similarly, for national roadway development, it is also told that difficult hilly area are to be taken up under PPP. Means government does not have budget for this. What is the proposed reduction? The proposed reduction, if we reduce the total budget of the road by say and health, which is total about reduction about say 10% in the road, it will give you about 1,991 crore rupees. And if you reduce 1% on the health, it will give about 133 crores. So finally, we landed up in 2,124 crores, which can be effectively utilized for the Indian Railway and the Metro. About 2,124 crore additional budget can be given for Indian Railway and the Metros. Auto reduction of the budget requirement. Once we give the more funding to the railways traffic, that is steel tire and the steel road, then the healthcare budget is estimated in the first year as reduced by 1%. In second year, it will be 2%. In third year, it will be 5%. And then finally, the target is to reduce it by 30%, because this 30% budget goes into the curing of the diseases related to your respiratory system. Road infrastructure budget requirements will also reduce. Initially, we have asked for reduction of 10%, and then we go to second year 20%, and finally the target will be 50%. So we have seen the means of transport. These are all means of transport. What transport is to be used and what is to be chosen for better health of the budget, economic health, as well as the human health of the people. So we have seen the advantage also of the metro system and metro light system. So now we decide to go for metro light. And finally, I request from all the industry partners who are in the business of auto sector, they should switch over their product to support the metro light system and earn out of it. This is all. Thank you very much. Have a nice day.